guys, Miss Brummel here. We're going to be doing 2.4 in this video. And we're going to look at, we're finding the derivatives of constant functions of y equals f of x, and we also learned about that simple power rule with polynomials. So now we're going to look at what happens when we have a product or a quotient. So first we're just going to explore. So let's consider we have these two functions. So what I would love is, here's my derivatives, right? Derivative f prime is 2, derivative of this would be 3x squared. So what I would love to see is the derivative of f times g the same as if I were to just find their individual derivatives and then multiply? So let's check. Okay, so if I were to multiply f of x times g of x and then take the derivative, here's what we would have. So f of x is 2x times x cubed would become 2x to the fourth. So if we took the derivative of this, we would get 8, right? Bring down my power of 4, 8 times 2, or excuse me, 4 times 2 is 8, and then my power decreased by 1. So would I get the same thing as if I just did f prime times g prime? So if we did the derivatives first and then multiplied. So if we took the derivative of f prime, so I'm doing this guy now, is 2 times 3x squared, we get 6x squared. So this relationship, right, those are not equal. So that relationship is not true. I can't take the derivative of each part first and then multiply. We don't get the same thing. So when I'm multiplying and I want to find the derivative of a product, there's a proof in your book if you want to see the proof using our limit definition of a derivative. But basically, here's what we come up with the product rule. Because this relationship isn't true, we had to find what is the correct relationship. And basically, here's kind of the shorthand of writing it. We're going to get, if I want to know what's the derivative of a product, so I can kind of write it as two functions being multiplied, it's the derivative of the first times the second plus the first times the derivative of the second. So f prime g plus f g prime. That's kind of the shorthand way to write it. You could put f of x in there as well, but this I think is the shorthand's a little easier to remember. Okay, so f prime g plus f g prime. So let's try that out on this example with the product. So I'm going to treat this first piece as the f of x, and then the e to the x I'm going to treat as g of x. So I'm going to use this product rule to find the derivative of this product. So we're going to say y prime. Okay, so the derivative of the first. So I'm going to write these out here so you guys can just see that. So f prime, the derivative would be, right, this would be 0, and then bring down my 2 would be 2x. G prime, so the derivative of e to the x is itself, okay? So if I use this equation, we've got f prime times the original g. So f prime is 2x times g, e to the x, plus, now I'm going to do f, which my original f was 1 plus x squared, and then my g prime is also e to the x. You can actually leave it just like this, you guys. Actually, in the AP test, when you are doing free response, you don't get any more points for simplifying. You can just leave answers as they are. Sometimes if you're asked to do something else, it's easier to do when it's in simplified form. For example, we're going to get to some higher order derivatives a little later. So when we can simplify, it might just make that next step a little easier. So I'm going to simplify for the purpose of that. But wanted you to know that you don't have to simplify on the AP exam. You can just put everything in its kind of long, ugly form. And if it's correct, you don't need to simplify. All right, so I can kind of see I've got two pieces here, two factors, and they both have e to the x in common, so I can factor out the e to the x. And then what would be left is 2x plus 1 plus x squared, right? This is a quadratic where I'm actually going to write it in standard form just so it's kind of more what we're used to seeing. So we got x squared plus 2x plus 1. This does factor nicely, so we can leave it like this, or we can write it in factored form. This is the same as x plus 1 times x plus 1, or x plus 1 squared. So either one would be fine, and honestly, that original one would be fine. All of these are acceptable answers for finding the derivative of this product. Okay, so let's try another one. So we have some options, you guys. We can distribute this first and then use our power rule, or we can use the product rule. Either one, we're gonna get the same thing. I'm gonna do the product rule just so, since that's new, we can practice it again. So here's my first product, so that's my F, and here's my G. So F prime would be, using my power rule, 10v minus 1, and G prime would be 3v squared. Okay, so I'm going to again use my product rule. So F prime G plus FG prime. So F prime, so we're finding the derivative of capital F here. Okay, so F prime is 10v minus 1, okay, times G, there's my original G, v cubed minus 1, plus F, here's the original F function, times G prime, and G prime was right there. Okay, so same thing, you actually can leave it just like this, or we can simplify further. Again, depending on what we're asked to do later, sometimes the simplified equation is more useful. I'm gonna simplify. So if I distribute here, let's see, we get 10v to the fourth minus 10v minus v cubed plus 1. Okay, here I've got, distribute that, I've got 15v to the fourth minus 3v to the third plus 3v squared. Okay, combining like terms, so my highest powers here are 4s. Add those, we get 25v to the fourth. The other thing I will say, you guys, most of the answer keys have simplified form, so just for comparing answers, this is a little easier. Third power's next. Squared, we got plus 3v squared, and then just v's, negative 10v, and then plus 1. So putting it in standard form, that's often how it's going to be provided as an answer key, so just makes that a little easier to check. All right. Okay, we also have a similar rule, you guys, when we were finding the quotient. So similarly to what we just saw with the products, their derivatives and their derivatives, the quotient of two functions is not equal to the quotient of their derivatives. So we have a different rule. Again, this is proved in your book with the limit definition of a derivative, but basically here's what we get for the derivative of a quotient. The top is the same exact order as the product. I'm going to use this bar as a fraction line. So we've got f prime g. Instead of addition, though, it's subtraction, which kind of makes sense. Multiplication and division are opposites, so the sign here is also opposite. And then we have minus fg prime over, so again, I'm using that as a fraction bar, g squared. Okay, here's kind of an additional piece of that, kind of goes with division, but if we have a function g and we know it's differentiable, the derivative of its reciprocal, so 1 over g, is this guy, negative g prime of x over g squared. Okay, so let's go ahead and find y prime. We're going to use the quotient. So I'm going to treat the top function as f and the bottom function as g. So we're just going to use this guy. So again, I'm going to need to know what is f prime. So f prime is going to be 2x. And g prime is just going to be 2. Okay, so now I'm going to plug in everything I have into our quotient rule. So we have y prime, f prime times g. So f prime is 2x times g, 2x minus 3, minus f, x squared plus 1, times g prime. Okay, all over g squared. Okay, again, I'm going to go ahead and simplify my numerator because this is easy, polynomials to combine like terms. So I'm going to get y prime equals, so here I got what, 4x squared minus 6x. I'm going to actually put this 2 here just to make it a little easier. So negative 2, distribute that. Okay, combine some like terms. That's still over our common, or not our common denominator, but our denominator of g squared. So let's see, we got combine like terms, 2x squared minus 6x minus 2 all over 2x minus 3 squared. Okay, so this one doesn't factor nice. I could factor out a 2, but I can't go any further than that, so there's nothing I can cancel or anything. So I'm going to leave it just like this. It's also good when you have a quotient rule and you have a denominator to state what x cannot be. So what would make this undefined, this derivative undefined, would be if x were 3 halves. So we'd give, okay, here's our derivative given that x is not 3 halves, otherwise the derivative is not defined. Okay, all right, so this guy, we have the derivative of 1 over x squared plus x. So I could use the quotient rule, or I can actually use this guy. This has the form 1 over g of x, where this guy is g of x. So if I kind of use this, this is going to turn into negative g prime. So g prime for me is going to be 2x plus 1 over g of x squared. So we've got x squared plus x squared. Okay? And again, you can leave it just like that. Really no simplifying we could do there. If this factored out nicely and we could factor out a 1, that'd be great, but in this case we can't. So we're just going to leave it just like that. In this case, there's nothing that would make, or I guess x can't be 0 here. Is that right? 0 plus 0. Yeah, so just x cannot be 0 there. Okay. All right. Power rule. We've already learned this. I'm just going to show it to you. We haven't done it with any integer or fraction exponents, but it still works for those. So just remember that the derivative of anything to a power, we bring that power down, and then the exponent decreases by 1, okay? And I'm going to write that as y prime. Okay, so let's try that for this one. So right now there's no exponent, but remember 1 over x is the same as, so I'm going to keep the derivative, x to the negative 1, right? 1 over x is the same as this. So then if it's in this form, I can apply my power rule. So we bring down the negative 1, so we got negative 1 times x, and we drop this by 1. So if that decreases by 1, it goes to negative 2. Typically, we don't consider something simplified if I have a negative exponent still, so this would be the same as negative 1 over x squared, right? To make the exponent positive, we move it to the denominator there. So that would be the derivative of 1 over x. Okay, square root of y. If I think about it as a power, y to the 1/2, those are equivalent. So if I want to find the derivative now, I can use the power rule. Bring down the 1/2, and then decrease the exponent by 1. Now, same thing if I want to write that as a positive exponent, we have 1/2 y to the negative 1/2. So to make it to the positive 1/2, we'd put it in the denominator. We can write it like this, or 1 over 2 times the square root of y. Okay? All right. 4 over s to the 5th, same thing. I'm going to rewrite it as a negative exponent and think of it as 4s to the negative 5. Apply our power rule. 5 times negative 4 is negative 20. Sorry, negative 5 times 4. And then drop our exponent y1, we get negative 6. To get rid of the negative exponent, we'd write it as negative 20 over x to the 6. All right. And I think that is all for this video, guys. Thanks for watching.